Hey, assalamualaikum, all of you. This is Mohammad Inam from SIPD, the Buddhist Institute for Professional Development, and welcoming you to a new webinar on calculations of percentage on telegraph. I hope you are all fine. Let's get into the webinar. So here is the learning outcomes. At the end of the webinar, the participants will be able to define percentages and its approaches to teaching regarding finding percentages of amounts and changing of percentage of same quantity, including external percentage. And the relationship between percentage, fraction, and decimal, and concluded the order of percentage does not affect. These are the learning outcomes of today's webinar. So let's start. Okay. So first of all, what is the first thing that comes in your mind when you hear the word percent? You can answer, or you can answer by turn on your mic and in the chat box as well. Yes, you can answer what is the first thing that comes in your mind when you hear the word percent. Yes, a part of every 100, that's great. Discount, that's application, yes. Anyone else? Everyone have different ideas and different words. So ratio, good, yes. Ratio is almost percentage. Anything else? If someone like to contribute? Proportion, okay. So basically, yes, these all are the things that relates with the percent. And let's go to the deep insight. So first of all, why we need percentage? Why we need percentage? We use percentages when we look at our battery life on our phones. When we are trying to use a specific service, when we are looking at pie charts, especially when we are looking at the sales at the stores. Yes, basically, all the time when we go to the malls and etc., we found that there is discount or sale, so that basically leads to the percentage. These are the applications of percentages in our daily life. Learning to use these percentages will help students become successful in life. It is not just about learning to change decimals to percentage or fractions to percentage. It is about learning to use these in the real world. What happens in the classroom? Teachers just teach the students how to find a percentage and what is the relationship between percentage and fraction and the ratio. But they didn't tell them how to use this percentage in your daily life. So in this webinar, I just try to explore the ideas how to use this in the real life. For example, look at this example. Air is a mixture of gases. If someone says what is air, everyone can answer air is a mixture of gases. But at what percentage they are mixed? No. So you can answer that the nitrogen is 78%. It means the mostly air is composite on nitrogen and 21% of oxygen. We have 21% of oxygen in the air and 78% nitrogen. And left are the other gases. This is you can answer and use the percentage in the natural sciences as well. So percentage is not just about the discount, profit, and interest, but they can be used in other areas as well. So here I have designed a little bit activity for you guys. What does a plant require? Give your answer in percentages. You can answer here, and for example, this is air, water, sun, seeds, egg. And what do you think? Which one is more important? Give a high percentage and as well in order. You can answer them in chat box. or if you want to like the mic, then you can answer it. Sure. Yes, please. You can answer them in order to priorities. Just for example, if you think seed is most important, you can give the high percent to seed. If you think water is more important, then you can give the less percentage to the water, and so on. You can guys come on. You can give your ideas. So Uzma will need to high percentage of water, medium percentage of sunlight. Yes, it's good. It can be. It's your own opinion. What is 40%? What about the other Anila person? What other percentage will you give to other factors? These all are factors, and maybe there are some more factors. So you can divide them in 100. For example, take 100 as a whole. Take 100 as a whole percent. And you can say that, for example, 40% water is needed, 20% is air, 10% is sunlight, and this is for 20, 30% is seed. You can divide your percentages and, for example, 0% to 8. For me, there's no work of 8 in the requirement of plants. So, yes, now try yourself. Yes, guys, come on, contribute some part in this activity. So, final answer sunlight 30%, water 30%, seed 30%, and air 30%, 10% others. So, yes, this is 100. Okay. Yes, please, sorry. Hello, yes, please.
Zoom meeting.
So 20% air, 20% sunlight, and so on. Yes, this is true. Everyone can give the answers according to their priorities. So the aim of this activity is just to introduce when activity or substance or thing material depends on multiple factors. So you can answer and figure out all the factors in terms of percentage. Please turn on your mic. Turn off your mic. Yes. So let's go to the next slide. So the next thing is that what is percentage? So percent is one of life's continuous problem. Everyone uses it almost daily. Sometimes without knowing it, percentages are typically easier to handle than fractions, as they are effectively percents, fractions with a denominator of 100, hence percent, which means out of 100. As I think Faiza Asghar has replied, percent means one out of 100. That's true. It's a definition of percentage. This makes it very easy to compare the size of percentages of same quantity. But remember that, for example, 1% of a large amount could well be bigger than 10% of a small amount. Let's see what does it mean by this statement. So this is, let's say these are chocolate bars. These two are chocolate bars of same size and everything else. So if the 10% of this chocolate bar is this area, yeah, this is 10% of this chocolate bar, for example, and this is the 50% of this chocolate bar. So both chocolate bars are same, but we can see that the 10% of is less than the 50%. So easy to compare. So here, this makes it very easy to compare the size of percentages of same quantity. Both are same quantity. We can decide the which percentage is bigger or which is small. Small. Okay, but here the next thing. But remember that, for example, 1% of large amount could well be bigger than the 10% of the small amount. So here I have two circles. Let me say this is the 25% of this circle. This 25% of this circle can be less than of 20% of this circle. Of course, because the sizes of these circles are different, so the 20% of this large circle is much bigger than the 25% of this small circle. So the percentage of different sizes would be different. Here is a little bit background. That person comes from shipping class, tried to save writing time. They did not want to write 100 on the reports. Ship owners used bundle of 100. So a partial bundle of 75 per 100 was shortened to 75 over 100, later 75 percentage, and the symbol percent means per 100. So these were the clerks who count bundles. So they invented the symbol, the percentage. So it is the background of percentage where percentage has been come. So now the next thing is to how to calculate percentage. Okay. So it's a mathematical part of the percentage. When calculating a percentage of an amount, many learners reach for the method of putting the percentage over 100 and multiplying by the amount over 1. As an example, 35% of 60 is calculated below using this method. So 35% of 60, ordinary people multiply 35 over 100 into 60 times over 1, and this is the 21. It's a 35% 60. And similarly, they just change the orders. First, they put the 60 after they, and then multiply by the percentage. And the answer is same because the integers hold commutative property, so this does not affect. Okay, this method works if you are good at arithmetic and can remember the procedure. The problem is with the student, they did not remember the procedure. They can understand this method, but they did not remember the procedure, and sometimes they are not good, very at arithmetic. So we need to have a new way to calculate the same percentage. Okay. For example, however, it is more intuitive to use some common knowledge that 10% is equivalent to 1/10, 1% is equivalent to 100, and 50% equivalent to 1/2, and 25% equivalent to 1/4. Other percentage can be worked out from these. So when we say 10%, it means we, we are just want to multiply by 1 by 10. And when we say the half, we need to divide the number by 2, the quantity, which will be 50%. So let's see this method by using this link.
Mathematical cakes are split into 10 equal slices. The whole cake is 100%, so each slice is 100% divided by 10, which is 10%. Here is a percentage question. Suppose the whole cake costs £3. How much would 70% of the cake cost? Well, 70% is 7 slices of cake. If we work out how much one slice, or 10% of the cake costs, then we can find the cost of 70% of the cake.
This sound is not clear. Still sound is not clear. Yes, someone replied. The sound of video is clear or not? Okay. I will explain after the video again. Okay. If someone missed the sound and did not understand the concept of mathematical cake, I will explain in the slide. Okay. Don't worry about it.
100% of the cake costs £3. So one slice costs £3 divided by 10. That's 300 pennies divided by 10, or 30 pence. We can write this as £4.30. One slice costs £4.30. Two slices cost £0.60. Three slices cost £0.90. Four slices cost £1.20, and so on, all the way up the cake. Finally, 10 slices cost £3. Now we can read off the answer to 70% of £3. Work out these other percentages using some mathematical cake. 40% of £3. Read across, and that's £1.20. 80% of £3. Read across, and that's £2.40. 50% of £3. Read across, and that's £1. Suppose the cake weighs 500 grams. Use the mathematical cake method to work out multiples of 10% of 500 grams. 10% of 500 grams is the same as 1/10 of 500 grams, or 50 grams. We can label the right-hand side of the cake going up in 50 grams. No slices weigh 0 grams. One slice weighs 50 grams. Two slices weigh 100 grams, and so on all the way up the cake. Finally, 10 slices weigh 500 grams. Then we can read off the answer to the following questions. 20% of 500 grams. 90% of 500 grams. 30% of 500 grams. Do these questions yourself, and then click on Reveal Answers to check your answers.
So here it was an activity that basically is mathematical cake. Okay. So due to I think sound problem, everyone is not clear. So let me just demonstrate it. For example, think we have a this is for example again a chocolate bar. If this is a chocolate bar and someone asks to find the 40% of this chocolate bar, so using mathematical cake that and the cost of this chocolate bar is say 10 rupees. Okay. So to find the 40% cost of the chocolate bar, so how can we find it? Using mathematical cake, we can divide this chocolate into 10 equal parts. Means that each part has a percentage of 10. And to so on, we need to divide them into 10 equal parts. So we need to find the cost of first 10 part, and then we can find the 40%. For example, the 100% cost of chocolate bar is 10 rupees. So what will be the 10% cost? It is easy to divide the 10, this both sides by 10. This will be 10% of chocolate cost is equals to 1 rupees. So the next is we need to find the 40%. We can just multiply 4 from both sides here. This will be 40% is equals to 4 rupees. This is basically idea of the mathematical cake video demonstration, and you can go for the further percentages as well. So still, so here is an activity for you guys. What percentage of 60 can you find? Try different percentages using mathematical cake. Okay, so let's answer in the chat box. Just try to find the different percentage of 60 without using mathematical cake. Some anyone can find the percentage of 50 and 15 percentage of 60. Can someone using mathematical cake? Yes, come on, please. 15% of 60. 9. Okay. And what about the, yes, it's good. It's good. What about the 39 percentage of 60? Can someone find this percentage? Yes, Anas, come on. Can you find the 39% of 60 using this mathematical cake demonstration? Yeah. Yes, but how you have calculated is not 22 or something. Do you have Usma? Okay, so we are running out of time. So click the link again and you will be get into the meeting again. Okay. When this session off done, please click the link again and you will be in the meeting again. But my question is to with Usma Muni, how you find the 23.4 Usma? Do you use the mathematical cake or something calculator? Okay. Um, can we find the 120 percentage of 60? Can we find this? Okay. Yes, this is actual way is not. Okay. Thank you. Can we find the 120 percentage of 60? Okay, whichever we have answered, that is 66. Can someone confirm it? Yeah, it can be 72, not 66. Yes, so if let me conclude it. What is the 10% of 60? 10% of 60 is 6. And we need to just multiply this 10 by 12, this, like this one. So here will be 120% of 60 is equal to 72. Yes, so 72 is the correct answer. So here we have actually learned the extended percentage as well. Is there any confusion or question we can ask? Yes, for 10% you multiply by the amount by 0.1. Okay, so what is the next thing? So far we have found percentages of amount by making reference to the equivalent fraction. As you have guide said, for 10% you have just multiplied the number by 0.1, and someone just like 39% someone have divided by 100, that is 0.39, and you have multiplied by the number. So you can see that the percentage have a direct relationship with the decimals and fractions as well. 10% equals to 0.1 as well as 10 over 100. So that's why percentage are more easy than decimal or to fractions, to handle fractions. Decimal equivalents can also be used when calculating percentage of amount. And this is a more helpful from when using a calculator. Remember that 10% equals to 0.1 and 25% equals to 0.25. And 10% equals 0.1 because it is 10 by 100, which is 0.1. And similarly, the 25%, which means 25 by 100, which is 0.25. And if I ask you, what about the 76%? What is the equivalent relation of 76% in decimal? So what will be the 76 equivalent relation of 76% in decimal? Can someone tell me what will be the decimal here of 76%? Yes, come on. Can someone tell me what should be the decimal relationship of 76%? Yes, it's 0.76, of course. So all the times when we have a percent, we can divide it by 100 and we will find the decimal relationship. However, for example, if calculating 76% of 60, the learner keys into the calculator 76 divided by 100 into 60, and you will have the 76% because the 76 divided by 100 is just like the 0.76 into 60. So instead of using this division, you can directly write the decimal relationship. However, it becomes easy to convert 76% straight away to 0.76 and then multiply by 60. Means we didn't need to write in this way into calculator. We just can write in 0.76 into 60 and we have our answer. It is worth raising a caution here about using the percentage button on a calculator. Since the percentage button functions in different ways on different Macs of calculators, so it is best not to use it. Instead, encourage learners to convert the percentage to a decimal and then multiply it by that. So when we need to find a percentage and it is a button in the calculator, directly we have a percentage button like in the calculator. We can do not encourage the learners to use this button because they work in different ways on the Mac of different calculator. It is better to use to convert the percentage into decimal and then multiply by the number. Okay, so here is the last activity. That is activity, does the order matter? Yeah, everyone, a customer goes into a restaurant and pays for a meal because they had the early bird menu. Their bill is discounted by 25%. There is also a 10% service charges added to their bill. What difference does it make to the customer's bill if the waiter deducts the 25% and then adds the 10% service charge, or alternatively adds the service charges first and then makes the deduction? So I want everyone to participate in this activity and answer, give your answer in the chat box. What will happen if the waiter first deduct the 25% and then add 10% charges, or first he add the 10% service charges and then deducts the 25%? Give your answer in the chat box or you can answer directly by using mic. Yes, come on. Try to find the answer. What happens if first he deducts 25% and then adds 10%, and first he add 10%, then deduct 25%? What will be the difference? Yes, come on, everyone. Give your feedback in this activity. A customer goes into a restaurant and pays for a meal because they had the early bird menu. Their bill is discounted by 25%. There is also a 10% service charges. What happens if the waiter deducts 25% first and then add 10%? Or alternatively, first add 10% charges and then deduct 25% discount? What will happen? What is the difference between in these two ways activity? Come on, guys, give your feedback. Okay, let me help you what solve this activity. Okay, so first of all, uh, let's say X R is total bill. First of all, set the R is total bill. We solve it generally. Okay, so if R is a total bill, first we go from the first direction. First, we will deduct 25%. So what will be the deduction of 25%? This is R divided by, so R multiplied by 0.25. This is our discount or deduction. This is deduction. So the total bill will remain 100 R, sorry, R minus R times 0.25. And this is basically 0.75 R. Means the 75 percentage of R means total bill. When we deduct the 25% discount, we will left with the 75 percentage of the total bill. Then adding the 10%. The 10% of total bill is R into 0.1. Add with the 0.75 percentage of R. And if we add them together, what will be the result? This will be 0.85 R. Okay, this will be the total bill. In the way we have first deduct 25% and then we add the 10% discount. Okay, now let's go this other second way. The second way, we need to add the 10% discount first. First, adding 10% discount, which is 0.1 times 0.10 times R, 200 plus 1 R. Means it is 1.1 R total bill. Now deduct 25% from this R, which is like 1.1 R minus 0.25 R. And surprisingly, it is again the same as 0.85 R. So here we have seen and concluded that the order of percentage does not affect your value or your bill, because the reason is they are commutative. It is just like we are just multiplying the numbers, and integers are commutative, so they didn't affect anything. So whatever you do first and second first, it doesn't affect, the answer will be the same or your bill will be the same as well. So here is the chat feedback form. You guys can fill this form and give your feedback again. I hope you have enjoyed this webinar. Come back again and when you fill the form, say done in the chat box. Everyone goes and fill the form, please, so we have idea how you have liked the session. When you fill the form, come back and drop message here, said done, so I can acknowledge it. If someone has any question, you can ask. Otherwise, let's end this webinar. Any comment, you can post it. Okay, thank you so much, all the participants. See you next time in the next webinar. Thank you, Faiza.